So, welcome back. Once again, this is Jeff Woods from iTelescope.net, ADB Jester on both Flickr and on Facebook. And as I've been discussing in prior videos, we are discussing how to get from here, or to get to here, from the original masters. In the last video, we combined all of the individual red frames into a master red frame, and in between I have stacked up the green, the blue, the hydrogen alpha, and the oxygen 3. So now we have all 5 master frames, and this becomes a very exciting time for our project, because for the first time we're about to see some color in our picture. We're going to combine the red, the green, and the blue into a standard TIFF image. TIFF images contain levels of red, green, and blue, and then later we're going to blend in the hydrogen alpha and the oxygen 3 in the appropriate places. But just like before, our images here are not properly aligned, and in fact, if you look, they're also not in the same star width. So let's look at the red, the green. Notice how they jumped down and to the left, and the stars are bigger. And the blue has the biggest stars of them all, and yet another location. So before we do anything, we want to try to get the stars to be roughly the same size. And the way we can do that is with a process called deconvolution. It's a form of sharpening. We're going to try and get everything close to about 3.0 in terms of star size in the full width half maximum. So let's start with the blue, and we'll do our deconvolution. The algorithm goes and looks at all of the stars, chooses a few stars, and comes up with a map of a typical star. Brightest in the center, spread out. The point spread function is what PSF is, so all the points spread out from the center of the star, becoming dimmer and dimmer as the star goes out. I think we can do about 25 iterations for the blue, and this takes a while. I'm going to click deconvolve and let it do its thing. And when it's done, we can see that the point spread function is now down to 3.35 from 3.75. We'll look at the difference between the two. Before and after. Look at those stars get smaller before and after. But they're still not as small as the red. So let's do that one more time. We got from 375 to 335, and we're trying to get down below 3. So let's do the exact same again, and hopefully we'll get about the same. And again, I'll pause and let it do its thing. Now notice that the point spread function is a little bit different. It's a little dimmer around the outside edge. That's because we chose different stars. So here we go, pausing. And there we go. We're down to 2.9 on the second deconvolution. Here's where we started. There was the first stop, and there's the second stop, even smaller yet. So beginning and end, and compared to the red, they're about the same. Still a little bit bigger. We'll have some blue halos, but not as much as we used to. So let's close. Oops. See, it's deconvolved. So let's close the original blue and the first deconvolved blue. And now the green is still up at 3.3, so let's run some deconvolution on it. Point spread function again. I'm not going to let this run all the way. I'm not going to let it do all 25 iterations. Let's stop it there, because it's already down to 2.82. Before and after. Before and after. So we're going to close this one. And now we have the blue, the green, the red, and our 2 specialty filters, which we do not need to deconvolve. Let's take a look. As we blink through them, they're in different places. The stars move around just like we did before. So once again, before we stack these on top of each other to combine them in color, we have to register them to one another. And what we're going to do is we're going to use the H alpha as the base image. This is where our sharpness is going to come from in our image. We're going to use the hydrogen alpha as our luminance. It's going to be what gives us the crispness, the detail, not the color, but the crispness and detail. So the color doesn't provide any crispness and detail. It just provides color only. So we don't care if we resample the red, green, and blue yet again. Hydrogen alpha, we don't want to resample, so we're not going to. We'll make it the base image, and we'll use all of the others to be registered to it. So let's do the register, stack register, align them all, just as we did in the past. We will check the error rate, all images aligned, 037, 019, 039, 025. Very good. Bicubic B-spline. I'll let it run this one time so you can get an idea of how long it takes it to crunch those numbers. And now, even though we're zoomed in to 600% magnification, as we blink through, the stars are all in exactly the right place, even if we show the pixels. So we're ready to create a color image. Before we do, let's save these registered data images as registered, so that if we ever need to come back to this point, we don't have to do everything we've just done all over again. So we are now ready to create color. So we can go to Color, Create. It chooses the red, the green, and the blue, and it also chose a luminance for us. We're not going to do luminance yet. We'll do that later in Photoshop. But what are these filter factors? What those are the camera and the filters are not as sensitive to the different bandwidths of light equally. This camera is much more sensitive to red. It's about 27% less sensitive to green, and about 47% less sensitive to blue. So if we want a star that looks white to the naked eye to look white in this image, we have to use 47% more blue and 27% more green, which is what these numbers do. That restores proper color balance to our image. If we'd combined this at 1 to 1 to 1, the image would have come out far too red, and that wouldn't be good. So let's go ahead and create our color. And there it is. Now you can start to see a little bit of color in there. Before I do any changes, I'm going to pull my DDP down, and oh look, there's my color. Now, it looks pretty green, and that's normal. We can set the color balance and desaturate the sky background by telling it what's black. Just like we did when we normalized, we tell it this is typical black, and it sees that the background is 1.04, 1.07, and 0.90. And it's going to shift all of those points and make that 1 to 1 to 1, because black has the same amount of red, green, and blue throughout. And we're also going to desaturate the background. We're going to take all of the color out of the sky values and leave it as mostly equal numbers. If it was 20 blue, red, and green, that would be desaturated. But if it was 30 red, 20 blue, and green, then the sky would be saturated red. This will take care of any saturation. Well, and that also took care of most of our star colors. The stars are now white too. So yes, let's apply that. Now our green flare around this star comes from the fact that the green filter is very sensitive to light from the fluorite in the telescope glass. So only in the green filter does this flare appear around stars. Now we can take that out later once we get into Photoshop. But now if we select our region, You can see that our RGB ratios are closer to 1 to 1 to 1. Now, because I chose a slightly different section of the sky, it's not going to be perfect, but it is much closer. And now we can see the beginnings of color in our image. And this is our color image. You can see orangeness in this star, and blue in this star, and this star. And you can see the color differences in this wisp of nebulosity here as opposed to the lighter nebulosity in the center. And if you look really close, there's some nebulosity out here, some very light red nebulosity all through here, and even up through here. There's some red that you can't quite see because the star field is so busy. But we're going to take care of that later. Right now, I just want to save our color image in 32-bit floating point format, and I also want to auto scale it back down to its original DDP state, and that's with our histogram munched all the way up against the left side, as it has been. But when we turn DDP on standard, we get a little bit of a stretch. Now I'm going to put a bit of a pedestal on it. I'm going to move it away from black being equal to 0 just a little bit so we have room to work. You still can't see much of the color down there, but that's okay. We will do all of those other adjustments in Photoshop. So not only am I going to save that as the 32-bit fits file that we can use here, I'm going to save it as scaled data. That saves the actual DDP stretch. That before we saved this. Now we're going to save this. So we'll do the file, save scaled data, this, and that's our color scaled. Now we can do the same thing with our hydrogen alpha. We can auto scale it, and that might be a little bright for what we're going to eventually do with it. So I'm going to turn it back down a little bit. I'll turn it back up later in Photoshop, but there are places where we need it to be turned down. I'll put that pedestal on it, and we will save this as scaled data ready for Photoshop. We're going to do the same thing with the oxygen 3 data, which is a lot noisier. We've got some data in here, but look how close the background is to our signal. So well, actually that had been auto-scaled. So all we have in oxygen 3 is this little bit down here. So we're going to once again move the black point away from the bottom. Now that's still pretty close. The DDP number is very close to the background number, which means there's not a lot of signal there. It's very typical for oxygen 3, not going to worry too much about it. We're going to save this. Well, no. We're going to save this as scaled data as well. And that's it. We're done in CCD Stack. So we can close all of the images, and we can now move on to try and create something like this in Photoshop. Okay, so here we are in Photoshop. We have all 3 images loaded. Our color, our hydrogen alpha, which contains an awful lot of the detail that we want to pull out of this image, and our oxygen 3. Now, how do we get all of this data together to look like this? Well, we have a lot of work to do. Our histogram is up here, and you can see we've pulled some of it out, but it's still only about a quarter of the image. Hydrogen alpha is about a quarter of the image, and the color even less, and it's still very homogeneous. Let's start with the color, and let's pull some of this information out. Now, I could just come in here and do what's called a gamma stretch, which is to squeeze all of this data here down. And so now this should be about half of the histogram, and this should be about half of the histogram. This should be the midpoint of the histogram. And if we look, that's exactly what it's saying it will be. About half the histogram will be contained with the midtones, and then the stars will be off to the left. Now that's one way to do it, and a lot of people do it that way, but that's not good. We can take that to an extreme, and look what that would do to our histogram. It's okay, but there's better ways to do this, so we're going to cancel this. That is bad because it's a linear stretch. It just takes half of it and moves it and stretches it skinnier. So this half gets stretched out, this half gets compressed to 50% linearly. Let's do this with nonlinear methods called curves. Instead, we can make this part, our nebula, watch the flashing circle dot when I click and hold down here. See where that is? That's what I want to enhance. Sky background here, not so much. Stars, way up here at the top, I don't want to enhance those at all. So if I make the, anything that's an input of 13 become an output of 54, I can slow the curve down near the top so that by the time you get to here, the input of 225 and the output of 242, we're really stretching the nebulosity, but we're not stretching the stars. We're not compressing the stars as much. So that allows us to always maintain our entire histogram. We will never clip off data and lose data when doing it with curves unless we do something silly like curve up there. As soon as that touches the top edge there, we've lost white. That's called clipping. If I show clipping, it would be there. I mean, I could clip horribly, and that's not what we'd want to do. But as long as we don't touch the sides, we can put in typical stretches that are nonlinear yet bring out the color that we want to see. Now, when this is done, let's put some sample points right here in the middle of the sky. 1, 2, 3, 4. And those are here, 1, 2, 3, and 4. And it shows us that the sky value is about 25 in each of these. That's good. The sky is not black. If I did that, that's good sky. If I changed the black points so that those were close to 0, 5s and 6s, that's very dark. And that's not what the sky is. Even when you look up at it from a very dark location, there's color to the sky. So we don't want to keep our sky much lower than about 20 to 25. Some people like a little bit of blue in their sky, so they'll go with 20, 20, 25. I'm a fan of right around 20 in all colors. So I'll set my black point there at 4. And that's good enough. Now I'm going to pull this off screen so we can see the color, but I'm always going to be keeping an eye on my 4 sample points so that I'm keeping the sky values right around 20. Now that's brought some color into these stars, and it's also brought our stars up quite a bit. I can step backwards and show you the difference. That's what it was when we opened it, and then we brought the curves up, and then I set the black point back down. Now, can we get any more color out of this? And the answer is yes. There's lots of ways we can get more color out of here. One of the tricks is called a 3-layer saturation. I don't remember who invented this, but I'm going to create 3 copies of the image in Photoshop's Layers palette. First one I'm going to blend with soft light, and the second one I'm going to blend with luminosity. Well, you know what? Before I do that, I'm going to make another copy so that we can see what this does. No, that's wrong. Merge layers. So now I have two layers. This is what it was before and after the saturation. Now it's very subtle. You might not even be able to see it. But if I were to zoom in down here, this is before and after. Before and after. Look right along this ridge of nebulosity, and I'm really pumping that up. Now the darker something is, believe it or not, the better the color is going to show up when I start doing the color. So I don't want to make that too bright. I might actually think that's too much. Just enough to give it a little bit of contrast. And that, I think, is what we want. So we will merge those. Now there are other ways of increasing the saturation. We're not really going to do it because this image is in really good shape for what we want to do later. Some of the things you could do are to do a hue saturation adjustment, where all you have to do is move the saturation layer and look at all that color get deep red. But look what it does to the stars. They get orange. If they have any color at all, they get really orange. This gets really bright red and doesn't do well in bringing color in. So we're not going to do that. Another thing you can do is to do an adjustment called shadow highlights. Now, this slider over here in shadow highlights for color correction is what gives us the power here. Now this, a lot of times when you add saturation, you add noise in the process. This tends not to, so I could bring this significantly up. Now it changes my black point, so if I did that, I would have to go back in with levels and set my black point so that my sky values were once again around 20, and that's right about where the sky values would be. So if you want to see before and after, that's before and that's after, but that's too bright. When we start merging our hydrogen alpha into there, that's going to blow it out and that's going to turn ultra pink. And we don't want that. That's not the color of the hydrogen alpha light we're going to bring in. So we want to leave this back here. Another method of doing this, right now our channels are red, green, and blue. I can look at just the red, or just the green, or just the blue. Or I can look at them all in a colorized manner. That's what's known as the RGB color scheme, but I can change the image to a different scheme. And one of the most useful is LAB color. Now we have lightness, A and B. Lightness is our brightness, our intensity, our sharpness and crispness. A is reds and cyans, B's are blues and yellows. So if I wanted to bump up my reds, I would do a curve on just my reds, on my A channel. Look at that, the reds came up. That's a little too intense, so if I wanted to not have as much, I could turn it down a bit. I'm not sure if that would be too much. We can I don't know if that's very subtle. I'm going to see how that works. That's before and after, just the ever so lightening of that, and it didn't really do anything to this dark purple, which is good. So I'm going to leave it like that, and I'm going to put this back into RGB mode because that's where we do most of our work. Now let's go work on our hydrogen alpha, because we're starting to get close. I mean, that doesn't look an awful lot like that, but we're starting to see some of the detail that we could see. If we come over to the hydrogen alpha, I'm actually going to make a copy of this. I'm going to duplicate this image because we need to use it in two separate forms. H alpha stretched. And the reason we do this is we do need to use the H alpha in its dim form like this, but we also need to bring it way up. Now that's clipping at the top. We don't want that. Whoop. Let's take that down. And look how far we've stretched that out, that histogram. That's pretty far. That might be too far. What we're looking for here is a very contrasty image, because what we want to do is bring out, see, remember I told you there was some stuff up there that you couldn't really see? Look where it is on the histogram. Look at the circle down there. It's very low. So this is what we want to stretch out. That stuff way down there around 13, 14, 16, 12, 18. That's what we want to increase. We don't want to do too much to the rest. But we want to get this and all of these little wisps in here. You can't really see them yet. And all of these little wisps down here to show up. So there is that. Once again, we need to set some sky value sample points so that we can keep an eye on our sky values, because we want them to match. Now these, since this is a grayscale picture, are in intensities of black, and about 92% is, it's actually not bad, so we're in good shape on that. So now we want to keep curving this up a little bit. Let's get this over here, so now we can really start to see what's up there. But there's an interesting problem we have here. We're going to use this as color, but the brighter you make this, the less color it will actually let through. So we don't want this to be too bright. We just want it to be very contrasty, yet we want all of this whiteness to shine through. So what we're going to do is we're going to be really aggressive and bring it down. Now look what that's done to our black point. If we do that and then fix our black point so that it comes back, hopefully we haven't lost all of our detail. Oh yeah, look at that. Now it covers the vast array of the spectrum. We're still looking at 89, 90, 91. One of them is at 98, but that's okay. But these aren't so dark that they won't soak up the color. In fact, if I wanted to, now that I've got the contrast in there, I could darken that down a little bit and bring up the top in a very mild S curve to increase the contrast. If I turn it off, you can see that. Now, I might be bringing that up too much. This might get too bright. I'm going to bring that down there, and I'm going to bring, you know what I want to do is this, and then bring that back down. Now, I think I've lost some of my contrast in that, though. That might be as good as we can get on that. I mean, we've really brought out the detail. We've got wisps here through here. We've got the little skull eyes and nose coming out up here. We've got what looks like jets coming off that star, and we've got all these thin little wisps down here. I might want to bring the black point down just a bit. Okay, now that is the color that we're actually going to import this directly into the red channel of the color image. Now, why would we do that? Well, our hydrogen alpha emits at a very deep red, very near almost near infrared, but it's visible but very dark. It might even be somewhat close to this color right here. So if we were to go look at only the red channel and copy all of that to the clipboard and then take it over to here and paste it in as a layer, now we have our red channel on top of our H alpha. And you see either or because we're in a blend mode called normal. But what we can do is we can take the best of both worlds. We can take the nebulosity from the hydrogen alpha, and we can take the brighter stars and color from the red channel. And then when we put it back into the red channel, the stars will still be the same. The way we do that is with a blending mode called lighten. And as we go up, I did the wrong one. I want to do the top one in lighten. And there, now you can see this is the H alpha with the stars from the red layer blended in. Now, they tend to get a little big. I'm going to drop that back to about 75%. Trust me on that. What I'll do here is show you this really quickly. We're going to zoom into 175% here, and on the red, we're going to zoom into 175%. And we're going to blink back and forth. Look at the stars. At 75% opacity, the stars are almost exactly the same as they were in the original image, which is what we're shooting for. If I were to up this all the way to 100%, the stars are actually a bit bigger than they were over here. You know what? In this instance, I think we might be okay. I think I'm going to leave it 100% this time. We're going to flatten this, and now we're going to take this new combined red with hydrogen alpha image and paste it back into the red channel of the RGB. Now watch this little thumb right here. We're only looking at the red. I could turn on the whole image and watch it all happen, but I'm going to turn only the red on and paste this back into the red channel. Well, look, now you got a hint, a little teaser of what just happened up there in the RGB. Let's go look at it. Wow, look at that. Because we kept the nebula dark, we've kept this as a very dark, rich red instead of a bright salmon pink. We've kept our star colors. We've captured the little nebulosity out near the edges. And we've captured the wisps through here. And if I zoom in, you'll see that our stars still look good throughout. So now we have a combined hydrogen alpha and color image. I am approaching the time limits of a YouTube video, so I'm going to stop here. In part 3, we will do exactly the same thing with the oxygen 3 into the green and blue channels, and then we will bring luminance over the top of this to clean up that nasty deep star field. I mean, those stars look great, but they obscure our nebula. Compared to our other picture over here, stars are very sparse, much smaller, and we can really get a look at the nebula that we had here before. Until we take the stars out of this image, it's going to be much tougher to see that nebulosity. So that's it for now. We will see you in part 3, and thank you so much for watching the integration of panel 1 of the Cygnus mosaic by ADB Jester.